Defining the payment or amount. Here's a formula that connects all these variables we're used to. S is the amount. That would be if we put in payments of size R, S would be how much we would have at the end. I is a periodic rate, and is the number of payments that we put in. Here are a couple of problems. Let's suppose we put $3,000 in at the end of each year for 40 years. At 7% real growth, find the amount. Well, state the formula. Number one, state the formula. Always do that. Define the variables. R is the payment, 3,000. That's right here. I is 0.07. That's right here. N is 40. That's right here. Substitute. Now the first goal at hand is to find that factor and replace it with a number. So we do 1.07 raised to the 40th minus 1 equals, to get your calculator to evaluate all that, divided by 0.07, that's the denominator, equals, and we end up with 213.92082. Now we're going to replace that, and then we see to calculate S, it's just a straight multiplication, and it gives us $641,762. That's a pretty tidy sum of money. If 7% real growth, that's what we'd have in today's purchasing power. So if you put $3,000 into a 401k, for 40 years, invest primarily in stocks, you'd have a pretty tidy sum. 3,000 is doable. If you have a matching 401k plan, that's it could be 1,500 you, 1,500 your employer. And not only that, it's pre-tax, so you may have to forfeit about $1,000 out of your paycheck. $1,000 out of your paycheck, $20 a week, that's a pizza. And a pizza a week will provide you $641,000, almost $642,000 in today's purchasing power. If you start at 22, that would be at age 62. That's a pretty good nest egg. Yeah, by the time you reach there, you may have other assets as well. It could have your house, Social Security. Social Security will be there, of course. How much must be invested at the end of each year for 45 years at 7% annual growth to have $10 million at the end? Now, that's a pretty tidy sum. So again, state the formula. Now, we're given the amount at the end. That's S. So S is 10 million. I is 0.07 and N is 45. Substitute. There's the unknown. Over here, I calculate this factor. I come up with 285.7493. Given all the zeros over here, we could keep more decimal places there, but if this is like a financial planning thing, well, we probably just want a ballpark estimate anyway. Now we substitute, then you can solve for R by dividing that by 285. So I show that here, and then to about $35,000. That's a pretty good sum of money, $35,000. If you had two professional members of a couple working, now that's probably pretty doable, especially if you have matching 401ks. May not get matching up to that amount, but you could. It could certainly be done. Of course, you have to wait 45 years. At age 22, you'd have to wait till age 67. Some scientists have predicted that within 20 years, the life expectancy is going to be 100. So working till age 67 is not that unreasonable in today's climate. So. Okay, there's two problems, and your problem set has similar problems. That's all for this video.